I've taken out the instrument panel just to have a look at the wiring. There's a lot of loose wires hanging around. So yeah, it's quite messy here. Some very strange connections. I don't know. Hey, how's it, Oaks, and welcome back. Hey, and a special welcome to the new subscribers. Thanks for joining us. So yeah, if you don't know me, my name is Duff. This is Rad Rods for Africa, a small one-man shop out here in the middle of a forest where I realize rusty dreams. It's time for some electricity. An old crackpot here. Let's pull some wire. Yeah, it's a chaotic mess. There's some very strange pad seams and bypassing of fuse boxes and all sorts of, I don't know, it's a mess. I'm just gonna rip it all out. I don't think I want to struggle with this mess. Well, for better or for worse, I'm ripping this whole wiring loom, wiring harness out of this truck. Just doesn't make any sense to me. Don't want to struggle to trace all this wire. I'm just going to redo it completely. Yeah, my way. Look, here's more speaker wire going up to the engine bay. I mean, what the hell? The concerning question to ask now is, what the hell does a fabricator know about wiring? There's one thing I can say for certain. There's not a single piece of electrical wiring left in crackpots. And that is what I dissected or dissected Ford F100 wiring harness looks like. Not too many oaks who can say that they've seen that, so count yourselves lucky. Whole pile of cut pieces of insulation tape, fuse boxes, plugs, regulator, etc. Nice pile of coiled wire. Here's the ignition switch with a lot of wires attached. Here's the steering column plug with a lot of wires attached. So yeah, call me a tight-assed scavenger, but I'm going to be using some of this to build my own wiring harness. I mean, why should I go and buy expensive wire? This is perfectly good enough. So yeah, let's see how that's going to turn out. So if I put the meter on, this is the wire that supplies power to the engine. And I switch ignition on, I get a bell. But when I connect to start, I get nothing. So I can see why the original ignition switch had a start button added. So this plug plugs into the steering column. And why there's so many bloody wires connected, I don't know. So like I said, I'm just gonna wire old crackpot here from scratch. I'm gonna do it my way, using good old common sense. And here's a disclaimer. I'm not a qualified auto electrician by any means. I have some experience in the solar industry with DC wiring. So yeah, if you are a qualified auto electrician, you'll probably nail my ass to the wall over stuff. So I'm not saying my methods are the correct way, but they do work for me. I've wired a few cars in my life, and they're all still working. Nothing has burned down yet. Let's get into it. So with common sense in mind, let's call this the first line of defense, the main line of defense. And I'm going to call this the main fuse block. So what have we got going on here? So power can come from the alternator through that yellow fuse and flow on into the battery. The power from the alternator can also go through the yellow fuse, through the green fuse, and directly onto supply. Supply would be the fuse box, the dashboard, ignition switch, lights, whatever is required. If the alternator is out of the picture, I can still get power from the battery through the green fuse and onto my supply. Engine might not be running, ignition switched on, I can get power from the battery, accessories, etc. So with my setup here, I currently have a 60 amp fuse here between the alternator and the battery, and this fuse then protects this circuit. If anything should go wrong in an alternator or in this circuit, that fuse will blow. The green fuse is a 30 amp fuse currently, and that protects the circuit between the battery and supply, dashboard, again ignition switch, whatever else. Anything goes wrong in this circuit, that fuse will blow. I made my main fuse block with some pieces of 1/4 inch perspex. I'll show you now where it came from. And I just glued it together, so it's gonna provide insulation for the fuses. I'm just going to screw this onto the firewall, and I might probably end up making a little cover here just to cover it up. So a few days ago, this sign was still happily hanging up there. And then when I came out with the RRR recovery truck, I brought it crashing down. Well, my father used to say everything happens for a reason. So now I've got some black perspex. Use what you have. So I made a little panel from the same perspex for the fuse box. This is just an aftermarket universal fuse box that I got from an auto parts store. And this little panel is going to now screw in on the inside of the firewall. So what's happening here is the power from the battery, the supply will connect to that point. So it's going to supply those 3 fuses. Let's call them hot, they will always be hot. It's a direct supply. You can decide how you want it. But that would be, for instance, for the brake lights and whatever else you want to be supplied with power, even if the ignition is switched off. So the power supply also goes from the same point on towards the ignition switch. So, and then if the ignition switch is switched on, the switch closes, and then the power flows and supplies power to these points. So those will be switched ignition. That will be power to the engine, meters, and whatever else requires power when ignition is switched on. You can pretty much configure it with common sense, I think. You could also have power that's switched on with the accessory side of the ignition switch, which I haven't wired in this case. Building this car for myself. I very rarely, if ever, uses the accessory part of an ignition switch, so I've decided to bypass it, because I'm also not going to be using a standard ignition switch. I'll show you later what I'm going to be doing. So when ignition is switched on, power is supplied to these points. Each particular one is fused, so the power will go through a fuse, and on this side the particular circuit is connected. Wiper motor, indicators or turn signals, that kind of stuff. Each one fused as required. So to recap, those 3 points will always be hot in this case, even if ignition is switched off. And these 5 points will only be getting power when ignition is switched on. Make a list of all your circuits and apply common sense and decide which must be a switch supply and which must be a direct supply. And if you have an accessory supply on your ignition switch, you can decide which must go there as well. It just makes sense that these guys here, engine, coil, gauges, wipers, turn signal, headlights, and if you have an electric fuel pump and heater fans, should be on the switch supply. So when the ignition switch is turned on, they get power. It does make sense to me that these guys could be direct supply. Brake lights, so even if the car is switched off, if you step on the brakes, the lights come up. Maybe tail lights, park lights, cabin light, and hazards. Depending on how complex your car is, how many accessories and circuits you've got, there could be more things added to this list. But this is an example of a relatively simple scenario. Let common sense prevail. As an example, you could argue that cabin light should not be a direct supply, because someone might leave the cabin light on even if the car is switched off and the key is removed, and then the battery can go flat overnight. So it could be better to put cabin light on the accessory part of your circuit. But then the cabin light won't work until you've put the key into the ignition switch and switched it on to accessory. You see what I mean? So make the call. So here's my fuse box panel installed under the dash. This thick red wire on the left hand side is the one coming from the battery, and then the two wires there is going to the ignition switch. And this is going to be my ignition switch. It's a 25 amp toggle switch. I think that should be fine. I don't want a bloody ignition switch, I hate keys. So I'm going to use this. So you can see on the one side is the hot wire coming in, that's the one from the battery. It gets switched, and this one then goes back to the fuse box to supply the circuits. On this side I've also got another wire connected, which is going to lead to my start button. So this is where I can start. The start button can then only work when the toggle switch or ignition switch is on. So what about wires for the engine itself? And remember, we're talking naturally aspirated old school engines, not this modern fandangled stuff with computer boxes and all the rest of it. So in its most basic form, we actually only need one wire to go to the coil positive, which is right there. And this wire is going to go to the ignition switch. So when we put the ignition switch on, we get power here to activate the coil. In my case, because I've got an electronic distributor, these two wires coming from the coil, one on the negative side, one on the positive side, is going to the electronic module. So what else would we need? The rest of the wires coming to the engine itself would be signal wires for sensors like rev counter, oil pressure, water temperature, etc. So I've got this one, this green wire, that is going to signal my rev counter. That needs to go to coil negative. And then this blue wire is going to go from the water temperature sensor to the instrument panel. It's the signal wire for the temperature gauge. And then I have one more. This red wire here goes to the oil pressure sender. So it's going to go from the oil pressure sender to the gauge, and that's the signal wire there. I have one final wire coming off of the engine, and that would be this one. That's going to the alternator for the alternator light. There's my water temperature sender unit with two wires in this case. The black one is a ground or an earth, and the white one here is then connected to this blue wire, and that's going to lead through the firewall and be connected to the water temperature gauge to provide a signal. Same story here with the sender unit for oil pressure. The black one is my earth or ground. Some of these sender units don't require that, they only have one connection point. And that red one, that is a signal wire, so that's going to go from the sender unit through the firewall to the back of the oil pressure gauge to get a signal from the sender unit. So I'm just going to tidy this mess up. and then put all the wires nicely into some sleeving so that it's nice and tidy. So now I've got my engine wires nicely sleeved and held in place with some P-clips so they're nice and secure. Can't move around, can't get melted or anything like that. So the only other wires coming from the engine are these two. This big red one is going through to the battery via a 60 amp fuse. Power can come from the alternator through that yellow fuse and flow on into the battery. And the brown one is going to the instrument panel for the charging signal light. So in my case I've got an alternator with a built-in regulator, and that's why I only have two wires. If you've got an external regulator for your alternator, it will be a different story. Spaghetti! Colorful spaghetti! What goes where? Help! I wired the original steering column plug to my instrument cluster. It's got 10 connection points and that's just perfect for what I want. So now I've got a plug and play instrument cluster. To see a video about how I did the wiring on my instrument cluster here, there's a link up here on the screen. So here's my starter solenoid. It's essentially very similar to a relay. It's an electrically activated heavy duty switch. So to activate the solenoid part, these two terminals are used. This one is earth to ground, and this one is connected to that starter button inside. So when I press that starter button, I provide power here, pulls in the solenoid and it closes the switch. And because it supplies power directly to the starter motor, it's heavy duty cables. This one is connected to the positive terminal of the battery. It switches through and this one leads on to the starter motor itself. Just so that you can hear the solenoid pull in, I'm going to go into the truck and press the starter button. But before I do that, I'm just going to disconnect the supply going through to the starter motor because I don't want the engine to turn over at the moment. So I'm taking this one off. So I've just tied this out of the way so that it's not touching here. Let's go push that starter button and see what happens. And this will be to start the engine. Did you hear the clicking noise? That's the solenoid pulling in and closing the switch for power to flow from the battery through to the starter motor. By the way, that background noise, excuse it please, it's the rain on my tin roof. And just an overview of everything that's going on here. Here is positive power from the battery to that point. At the same point I've got this thinner red cable connected, and that it goes through to here, and then through this green fuse I'm now supplying the fuse box on the inside of the car or the truck. At this point here is the cable coming from the alternator is connected right there to that 60 amp fuse, so it can then supply through here to charge the battery and also supply directly to the loads inside the truck. My homebrew fuse box panel installed. To explain a little bit, this thick wire here comes from the battery, actually from the main fuse box. So there's power here. From there it leads to these 3 points, so that's always hot. This one goes on towards the ignition switch and brings power back to supply these 5 fuses when ignition is switched on. The thinner red wire here leads off to the relays for the headlights. And then on top here you can see wires connected that now leads off to various loads. Meters, wiper motor, that kind of stuff. So yeah, if you've got a labeling machine, you can label these wires. I've used different colors and I've just written it down in my little black book, so I know which is which. Let me get it quickly. Here's my little black book. where I've written down the colors of the wires at the fuse box, so I know which goes where. The thickness of the wires you use is important, and a good way to understand it is to look at the electricity and compare it with water. So then let's look at wires then as pipes, and it would make sense that the more water you need to take through the pipe, the thicker the pipe needs to be. So I have reused a lot of the original wiring. There is some new, like these red ones, and I can probably talk a lot about wire sizing, but it's actually relatively easy. You do get tables that tells you what wire size is suitable for how many amps it should carry. So then you just got to keep in mind the amps required by the load and the distance that you need to go to pick the correct wire size. So yeah, this is then the main supply pipe, and you can see it's a thicker pipe than the other pipes or cable sizes then, because it needs to be able to bring enough current to supply everything if need be. The wires up there is a lot thinner because they only have to carry a smaller amount of current depending on that load. On this side of the fuse box, 1 square millimeter, I think that's 18 gauge in America, is adequate for most applications. And that is my complete rat style ignition switch. This toggle switch under the dash here is ignition on. And this will be to start the engine, and ignition off. I use one of the aftermarket turn signal switches. Right indicator or turn signal and left indicator or turn signal. They are relatively straightforward to use and to wire. They come with their own wiring diagrams. They even come with a hazard switch. So for my taillights, I've just run a piece of 5-cord trailer cable along the inside of the frame. Yeah, you can see one of the P-clips holding it nicely in place. So this 5-cord trailer cable makes it simple, and it's got enough wires for the taillights itself. So it divides, goes to one taillight and comes along to the other side for the other taillight. And if you can see past all the dust, that's what I did for a brake light switch. It's just one of those micro switches attached to a bracket, and then when I press the brake pedal, if you listen carefully, you can hear the switch making contact. So I've got my taillights all hooked up. Let's see if they work. That should be taillights. That should be brake lights. Awesome. I got the air on installed here under the front end. There's the power cable attached with some nice P-clips leading back to the cab. And so instead of having a on button on the steering wheel, there's a childhood fantasy realized with my overhead handle that you can pull. I made my handle from an old piece of V-belt. And the lever up there is an old rocker from an engine. Right in there I've got a push button type switch installed. True ratchet style. So now I can sit here behind my steering wheel and imagine myself to be a real mother trucker. Hey, get out of the way! I love it. So this video is getting quite long. So I think I'll be doing a separate video specifically on headlight wiring. So I hope my common sense approach, forest engineering style to basic wiring has enlightened at least someone. If you have any comments or questions, or you think I'm going to burn down something, let me know down below. Thanks very much for watching. I'll see you next time when we do headlight wiring. Have Have a good one.